Now we want to find the polar coordinates that correspond to x equal 2 and y equal square roots of 2. Well, perhaps the most straightforward is to find r. We know r squared is x squared plus y squared. So r squared is 4 plus 2, or 6. So r is the square root of 6. So there's our first coordinate. Now, we know that the tangent of our angle measure is going to be y over x. For what angle measure, we're after theta, is the tangent root 2 over 2? Well, this is a little confusing because this sure looks like an exact value. And we might be tempted to say that theta is pi over 4. If this was the sine of theta is root 2 over 2, or the cosine of theta is root 2 over 2, then it would be true that theta was pi over 4. If this was the tangent of theta equals 1, it would be true that theta could be pi over 4 or 5 pi over 4. But this is going to be a decimal approximation. So we're just going to say that theta is the tan inverse of root 2 over 2. Now, you're welcome to, and you would need to, if this was a calculator active question, put that into your calculator. Please make sure you're in radian mode. It's very important. We're always in radian mode in this class. And find the decimal approximation and list it to 4 decimal places after the decimal point, right? So you can pause the video and do that if you want to, but that would be the polar coordinates, r comma theta, for these equivalent Cartesian coordinates. Now let's talk about graphing polar functions. There are 2 major types of functions that we're going to be responsible for graphing. Limacons or limacons, depending on how technical you want to be. That's actually a different letter there. I was taught by Oklahomans, so these were taught to me as limacons, but technically they should be pronounced limacons. But you're going to hear limacon out of me because that's what I've heard. Get over it. Okay, so we have 2 types, limacons and roses. So when graphing these by hand, since they are non-calculator active questions, we're going to look for trends or patterns or clues that might help us determine, based on the pieces or parts of our function that we're given, can we take any shortcuts to determine what the graph might look like? And it turns out that we can, because on a limacon we have r equals some constant value. A and B are just any real number constant values. So if we have that, we're going to have a plus or a minus following it. Then we are going to have another constant. Now remember, it could be 1. A and B could be 1. It's any real number. Then we're going to follow that constant value with either sine or cosine, and then we're going to have an angle measure. So can you see, all I've done is kind of sort of put those 2 forms together because they have lots of things in common, and there are really only 2 differences. So whether it is sine or cosine that is in your polar function as it's given to you plays a role in what the graph will look like. Whether there is a plus or minus, once we look at roses, that'll be more apparent to you. But whether there is a plus or minus in your polar function is going to play a role in you recognizing you're dealing with a limacon and what that graph might look like. The fact that you have a single angle measure, it's not 2 theta, 3 theta, 4 theta, it's a single angle measure of theta, plays a role in recognizing that we're dealing with limacons. And if we are, there are some things that we need to know. We need to know that A and B play a big role in landmarks on these limacons. All limacons, for the most part, look like this. They intersect either the x-axis or the y-axis, and we'll discuss how we're going to determine that. A distance of A, and this is the same A as right here. This A, this A, this A, and this A are all given to you in your function. R, remember, is some function of theta. If we can determine what that value of A is, then we know from the pole a distance of A, either along the y-axis or along the x-axis. Our graph should intersect the axes. A distance of A plus B, you look at the red arrow, your graph should intersect the axis that is not involved in this distance of A. This would be called the major axis. We could, although this is called many things, we could call this, for clarity, the minor axis. If, and I say if because not always true, if there is an inner loop in our limacon, then the distance from the pole along the major axis to the end of that loop, from the pole to the end of the loop, that distance will be B minus A. Again, there's the B I'm talking about. So if I give you a limacon or a polar function, and I tell you that it is 2 plus 4 cosine theta, then I've told you A is 2, I've told you B is 4. By telling you cosine, I've told you the major axis is the x-axis. That's what we get from cosine. So I've told you a whole lot. You need to do a comparison between the values of A and B. If you determine A is less than B, then you have a loop. And you know you need to draw that loop. We know the distance along the major axis from the pole to the end of that loop is B minus A. We want to look for trends to determine whether we could graph a limacon that was given to us. When we have a polar function where A equals B, then we have no loop. But everything else is the same. If I gave you this equation of a polar function, I'm telling you A equals 1. I'm also telling you B equals 1, because remember, cosine of theta is going to have a coefficient of 1. So I'm telling you A equals B, and we have that special kind of limacon called a cardioid. It's called a cardioid because it looks like a heart. I gave you cosine of theta, so the major axis is the x-axis. But there's actually more to glean from the plus sign. The plus sign tells me that the majority of the graph will lie on the positive end of the x-axis. If I gave you r equals a minus b cosine of theta, then I would be looking at that cardioid. The majority of the cardioid of the function itself would lie along the negative end of the x-axis. This tells me x-axis. This tells me which end of the axis. You could also guess that if I gave you r equals 1 plus the sine of theta, now I've told you the major axis is the y-axis, and I've told you the majority of the graph is on the positive y-axis. So now the x-axis becomes the minor axis. I'm going to go from the pole to -1 and to 1. I won't have a loop. A equals B. This tells me the major axis is the y-axis. This tells me the majority of my graph lies on the positive y-axis. Additionally, could you guess what the graph of that limacon would look like? And could you draw it? You need to consider A. You need to consider B. You need to consider whether we're on the positive end or the negative end of the major axis, and you need to consider which axis would be major, therefore which would be minor. So although this looks terribly, horribly, awfully complicated, it's really not. There's a lot of information that you're being given in A, B, sine, and cosine. So here it is, pretty straightforwardly. If I have, and I have y here, but normally that's given to us as r. If I am given r equals a minus b cosine of theta, or t, then I do need to determine the relationship between a and b. That tells me whether I have a loop or not. Here they're all equal, because you can see that all these graphs are cardioids. But depending on whether it is less than, equal to, or greater than, it determines what happens at the pole. But right now we're just concentrating on the minus or the plus part and the sine or the cosine part. So minus cosine, major axis x-axis, most of the graph on the negative end of the x-axis. Plus sine, major axis y-axis, majority of the graph on the positive y-axis. Minus sine, major axis, the y-axis, the majority of the graph on the negative y-axis. Now we said before, if A is less than B, there is a loop. If A equals B, no loop. There is a third special case where A is greater than B, and there is no loop, and no intersection at the pole. Kind of just a flat side on the major axis that intersects at a distance of b minus a. We don't see this one very often when we're asked to graph by hand. Most of the ones we're asked to graph by hand are ones with loops or cardioids. Not to say that we're not responsible for this, we are.